Welcome to this problem solving session on the course Introduction to Abstract and Linear Algebra. My name is Harshita. I'm a PhD student at ISA Tirupati. So today we'll discuss some problems related to the contents of week 5 of the course. So yeah, we'll start with the problems. Okay, so this week we've started linear algebra and looked at some basic things like what is a vector space, subspace, dimension, and so on. So most of the problems will be related to these concepts. Okay, so this is the first problem. We have a vector space V and dimension of V is given to be 6, and we have two subspaces U and W, and it's asking what is the possible dimension of U intersection W. So let us look at a few examples before we jump into this problem. Let's just look at some visual pictures to understand what is happening. Okay, so if is there any questions on the concept of dimension or anything just related to the question? Is there any questions?
No, ma'am.
Okay, so let's just look at R2. So this is a two-dimensional space, right? So we'll just look at few examples. Dimension of R2 is 2. So how does it look like? We have our plane and we will look at something. Let's just look at this line and let's say this line. So we will come to the point of checking whether these are subspaces and everything. For now, let's just, you take it for granted that these are subspaces. Okay. So if you believe me that these are subspaces, what is the intersection? It is just 0, right? So the dimension of U intersection W, it is nothing but 0. Let's look at an example in R3. So dimension of R3 equal to 3. So we have 3 coordinates. So this is the y-axis, x-axis, let's say z-axis. And let's take one subspace which is some line. So again, if you are confused about why is this a subspace, all this will look at it. So you just assume that it is so for now. And let's take some other plane. Okay? Something like this. So the line is not contained in the plane. You can imagine a plane and some line which is not inside the plane. It's coming out of the plane. So again here the intersection is just the 0, right? So what is this? U, W. Okay. So dimension of U intersection W is 0. But on the other hand, if the line is actually inside the plane itself, then the intersection would be the line itself and the dimension would be 1. Okay? So this is just a very nice way of imagining things to just give you an idea of what is happening. So here what do we have? We have a vector space V. We have two subspaces and we know the dimension of all these 3 spaces. So we have U and W. So subspace of V. What do we know? Dimension of V equal to 6. Dimension of U is equal to dimension of W which is equal to 4. And there's one more point given in the question. It says that they are distinct four-dimensional subspaces. So, which means W is not equal to U. They are distinct means W is not equal to U. So, the question is, what is the dimension of the intersection? So, there is one formula which you can derive. So, dimension of U plus W equal to dimension of U plus dimension of W minus dimension of. If you remember, we did something like this, for set theory. So you can just have this analogy. Analogous to the Does anybody remember uh, some formula in set theory which looks somewhat like this? No, or too basic. Okay. So if you had two sets, A and B, we had this thing.
N of A union B is equal to N of A plus N of B minus N of
Exactly.
A intersection B.
So you had the cardinality of A union B equal to cardinality of A plus cardinality of B minus cardinality of A intersection B. So you'll see that even when you prove this, somewhere this may be used. So where N of A is cardinality of to not lead to unnecessary confusions, let's take finite sets. Okay. So going back to this formula, let's just substitute whatever values we know. So what do we know? We know dimension of V, we know dimension of U and dimension of W, right? So directly we do not see how to use dimension of V. The dimension of U and W we can substitute. So let us just substitute that. The dimension of U plus W equal to 4 plus 4 minus dimension of U intersection W, which gives dimension of U intersection W equal to 8 minus okay. So, sorry, is there any question? Okay. So, what can the dimension of U plus W be? See, we know that U plus W is a subspace of V. Is a subspace of V, right? And we know the dimension of V is 6. So what can be the dimension of U plus W? It can be at most 6, right? If it's a subspace of V, then the dimension of the subspace has to be less than or equal to the dimension of the bigger space. So yeah, so minus dimension of u plus w is greater than or equal to minus 6. So now you use equation 1 in equation 2. What do we get? Dimension of u intersection w, which is equal to 8 plus, I can write it as minus dimension of u plus w. This is greater than or equal to, this part we will substitute it with minus 6. I mean, you know that it's greater than or equal to minus 6. So 8 minus 6, which is equal to 2. Right? So these two subspaces have to intersect in at least a two-dimensional subspace. That's what it says. Now let's go back to the options. So you see three numbers greater than 2, greater than or equal to 2 here. But let us look at the possibilities. So possible dimension for u intersection w, when I say possible, out of the options given, okay, is 3 or 4 or 5. Okay. Now you have that u intersection w is contained in u, right? And dimension of u is 4. So you have something smaller than u or a subspace of u. So dimension of u intersection w should be less than or equal to dimension of u, which is 4. So definitely this rules out the possibility of having 5 as an option. So dimension of u intersection w cannot be 5. So now we are left with 3 or 4. Okay. Now let's look at, is 4 possible? What happens if dimension of u intersection w is 4? So you have this u intersection w is contained in u. U itself is dimension 4, and you have a subspace of a dimension 4 subspace, which is of a dimension 4 vector space, which is also dimension 4. So what can we say? What I'm saying is you have v, you have w, and if I say dimension of v equal to dimension of w, what does that mean? Can you conclude something from this? It's just a one line answer. You can type it in the chat box if you don't want to unmute yourself. Is the question clear? We're saying we have a vector space of some dimension and we have a subspace of the same dimension. What does that mean? Can you conclude something? Infinite solution of what?
Both will have the same number of elements.
You can say same number of, okay. Any other answer? Yeah, exactly. Subspace should be the whole space given. See, we can't say same number of elements because they are both infinite, and most of the time, if you're taking fields like real numbers, complex numbers, they are both uncountable. So I think what you meant to say is they are actually the same spaces. I mean, it was a close answer, just a more precise way of saying it is W has to be equal to V, right? You can just look at it in R2 or R3. If the dimension, see, whenever you take a proper subspace, the dimension drops down. So intuitively it seems like that, right? You can actually give explicit proofs also. So in fact, if you have a vector space and a subspace whose dimension is the same as the vector space, then the subspace has to be the whole space. So now let's come back to our question that we were looking at. So we were looking at the possibility of W intersection U being dimension 4. So if that happens, so we have the same condition, right? So we have U intersection W is contained in U and dimensions are equal. So what do we, using this, what we conclude is U intersection W equal to U. And similarly, we can do it for W. There's nothing, no difference, right? So similarly, U intersection U intersection W is contained in W and dimension of U intersection W equal to dimension of, here it should have been U. So from here we conclude that U intersection W equal to W. And using these two equations, we get U equal to W. But what were we given? So we were given that U is not equal to W, right? So that tells us that the dimension of U intersection W cannot be equal to 4. So since we are given that U and W are distinct, dimension of U intersection W cannot be 4. So the only possibility left is it has to be 3. When I say the only possibility, I am saying out of these options. Of course, it could have been 2 also. Is this clear? Any questions?
What about one, ma'am?
One that we already, okay, so the first analysis that we did using this dimension of U plus V is, this formula, we concluded that it has to be greater than or equal to 2, right?
Okay, ma'am. Okay. Okay. Yes.
Any more questions?
No, ma'am.
Okay. We'll go ahead. Okay. So this says let P2 be the vector space of polynomials of degree at most 2. So what is P2? So it is A0 plus A1x plus A2x square such that A0, A1, A2 belong to real numbers. And you are given a basis of this vector space. So this will be a 3-dimensional vector space and they have given you some specific basis. So you are given 1, 1 plus x, 1 plus x square. This is a basis of P2. And the question is, what is the coordinate of some polynomial, some vector in P2? And when we say coordinate, see, we know that any vector can be written as a linear combination of the bases, right? So when we say coordinate, it means what is the linear combination? Okay, so let's just look at an example. So let's take 0, 1 and 1, 0 is a basis of R2. So the coordinate of any vector, let's say 4, 3. So what does it mean? You write it as a combination of these two basis vectors, like in the same order. So first you have to write it as alpha times 0, 1 plus beta times 1, 0. Then the coordinate will be alpha comma beta. Okay, so let me, since I've taken a vector, instead of, so you can write it as 3 times 0, 1 plus 1, 4 times 1, 0, right? So the coordinate of this, the basis is very important. So with respect to the basis B1 is 3, 4. It is these numbers 3 and 4. Let's do a different thing. We'll take a different basis of R2. Not very different. Let's just interchange these two, the order of the basis. So this is also a basis of R2, a different basis of R2. Here the coordinate of, so when you say coordinate of 4, 3, what will it be? You write this 4, 3 in linear combination of this, keeping the order of the bases same. So you can write it as 4 times 1, 0 plus 3 times 0, 1. So the coordinate with respect to this basis B2 is 4, 3. Right? You can try it with another basis. Let's say 1, 0 and 1, 1. And yeah, you can try this. Is this clear? What is the meaning of the coordinate? Any questions?
No.
No, ma'am.
Okay. Then we'll go ahead. So what do we have? We have this particular basis 1, 1 plus x, 1 plus x square. And we want to find the coordinate of 1 minus x the whole square. So what should we do? 1 minus x the whole square. We have to write it as alpha times 1 plus beta times 1 plus x plus some gamma times 1 plus x square. So we'll just expand both sides. Change this to ABC. So what is this? 1 minus x the whole square is 1 plus x square minus 2x. This is equal to a plus b plus bx plus c plus. So our task is to find out what is ABC. So cx square. We'll just combine all the constant terms plus bx plus cx square. Now you compare the two polynomials, right? So you have a plus b plus c equal to 1. The constant terms should be equal on both sides. The coefficient of x is b here and minus 2 here. So we get b equal to minus 2 and coefficient of x square is c, which is 1. So using these two we can get the value of a. So gives the value of A to be B plus C is minus 1.
2, ma'am.
Yeah. So the coordinate should be A comma B comma C. Net of 1 minus x the whole square is 2 comma minus 2 comma 1. So that is this one. And as I said, this is important. It's relative to a particular basis. Any more questions?
No, ma'am. Proceed, ma'am.
No. No, ma'am.
Okay, let's go ahead.
Yes.
From the following options, choose the suitable value of k for which three vectors become linearly dependent. So, does anybody want to suggest a way of doing this?
Ma'am, determinant should be equal to 0, no?
Yeah. So, can you explain why determinant has to be equal to 0? And determinant of what?
Ma'am,
Okay.
Determinant of the matrix is equal to 0, so that it will be dependent.
Yeah. So, can you tell me what is the definition of dependent? What do you mean by these three vectors are dependent?
ma'am, there exists a linear coefficient through which combination we can, I mean, get the equation value 0.
Yeah, we can get the equation value 0 through some linear combination. Just one small point I would like to add, through a non-zero linear combination. See, if you take 0 times the first vector plus 0 times second vector plus 0 times third vector, you can definitely get it 0, right? But there is some non-zero linear combination by which you can get it as a 0 vector. So,
I mean, all the coefficients should not be simultaneously 0.
yes, exactly. Okay, so let us just write it. 1 v2 is 1k minus 1, v3 is 1 minus 1k. So v1, v2, v3 is linearly dependent if, so you have to get three constants which are not simultaneously 0. So I will just write it this way, that this, no, this is just saying that A, B, C are not simultaneously 0. I hope this is okay. Such that A times B1 plus B times B2 plus C times V3 equal to 0. Right? What does that mean? A times K1 minus 1.
Hello, ma'am. You can equate any one vector out of three with the linear combination of other two.
Yeah. So that is equal. So this, okay. So if you want to write that way.
Yeah,
So this
that
is
will be easy.
equivalent to saying
Any one vector.
that will be easy in certain cases, but here how would you move from that to finding out a value of k?
You can get a value of k. You will get the equation, quadratic equation in k. If you compare the any one vector with the linear combination of the other two,
Mm-hmm.
if you equate that any one vector with the
Okay.
linear combination of other two,
Maybe I'll write what you're trying to say. It will be clear for others. So you're saying what he's trying to say is these are linearly independent means there is some vector. Dependent means there is some vector which can be written as a linear combination of the other two. So which one
Yes.
would you like to choose? There is a confusion there also, right? You don't know which one is a linear combination of the others.
Any one vector out of it. You can take
Okay.
first also k1 minus 1.
So let's say V1 is equal to AV2 plus
Yeah,
BV3 for some A and B.
right.
Both are non-zero. Okay, it doesn't matter. Anyway, now how would you go ahead, sir?
Then you write that first vector v1
Okay.
as k1 minus 1, which is equal to a times 1 k minus 1 plus b times
Mm-hmm.
v3,
Mm-hmm.
which is 1 minus 1 k.
Okay.
Then you add this, so that is a plus b, which is equal to k. Right.
Okay.
Uh, so a plus b, a
Sorry.
plus b is equal to k.
A equal to K. AK minus
K
B
minus b
equal
is
to
equal to
1
1.
minus A plus BK equal to minus 1.
Ma'am,
Mm-hmm.
uh,
So we will get
this we can
so
get
it would
after
be
solving, after getting the value of A, B, and C, no? Because at present we don't know whether there exists ABC for this or not.
Yeah, no. See, we know that there exists some ABC. They're saying if it is dependent, can you find the value of K?
yes, we can find.
First
Yeah.
find the value of ABC, no?
So we
Okay, how will you find the value of ABC?
Ma'am, through the matrices determinant form.
Yeah. So that is one way. That is definitely one way. We'll come back to that. But since he
So
had a
after
suggestion,
getting those value, we can, come to this equation.
after getting that value, we'll directly get the value of K. We'll look at that. But since he's suggesting somewhere, let's see if this also works. Yeah, so how do you continue from this point, sir?
substitute a for k minus b in first equation. A k minus b is equal to 1, no?
Okay.
Substitute a for a as k minus as k minus b.
So,
Yeah.
Ma'am, we won't get like this. We will again come back to our original form.
yeah, that's what I think also. But let's finish it since we've.
Without solving equation, how can we get the value?
I mean, even I don't think this will go ahead. This will proceed, but uh, yeah. So if you have tried it, maybe you can go ahead. I'm not sure. I think we'll get the same thing on both sides. If you want, I can go ahead with it. It will take some time. So can we try this after the class then? Like whoever is
Okay.
interested can stay back and we can try it. Is that okay, sir?
Okay. I solved one such question in the assignment like this, and I got the answer. I got the answer of k.
Okay. Then maybe it's possible. We'll probably do it together after the class for whoever wants to stay back. So the determinant one is probably a slightly more easier one. So what is happening there is, so let's go back to that. So we have AV1 plus BV2 plus CV3 equal to 0, right? So what does that mean? A times K1 minus 1 plus B times one K minus 1 minus 1K equal to 0. So what does this mean? AK plus B plus C. So
C.
equating the sums plus C equal to 0. A plus B
BK.
minus C equal to 0. Minus A minus
A
B
plus
plus,
BK, madam. I mean, A plus BK.
which means second one. Yeah. Thank
Second
you.
one BK.
Right? So what does it say? When we say it is linearly dependent, we are saying that there is an ABC, not all three of them 0, which satisfy these three sets of equation. So if you treat these ABC as variables, you know that there is a non zero vector satisfying this equation. So when we write it in the matrix form, what are we getting? K11, 1 K minus 1, minus 1 minus 1 K times the vector ABC equal to 0, 0, 0.
Ma'am, a screen hanging is lagging.
Oh, okay.
Screen is okay.
Okay, then
Okay,
probably it's
it's not.
internet connection. Okay. You
Yeah,
can
it
see
is.
now, right?
Yeah.
Yeah, now fine.
Okay. So what does this mean? That this solution or this matrix, when you multiply with some non-zero vector, is giving a vector. So which means that the matrix cannot be invertible, right? That's just the theory of basic linear equations. So if we call this matrix A and this vector as x equal to b, so since x is not the zero vector or 0, 0, 0, Ax plus b has a non-trivial solution. So if you look at your school mathematics, it means that A cannot be invertible. And this is equivalent to saying that determinant of A is 0. Now you go back and see what was the matrix A. Uh, yeah, so it is, you look at each column of the matrix, it is basically these vectors. K1 minus 1, 1K minus 1, 1 minus 1K. So that's what he was trying to say, that you can directly use this. This was just explaining why we are doing the determinant is 0. So if you have a bunch of vectors, if you want to check if they're linearly independent, just write it as columns and see if the determinant is 0 or not 0. So here, if the determinant is 0, so K11, sorry, K minus 1, 1 minus 1K. So determinant of this is 0. Now you will get a quadratic equation.
Yeah, ma'am. K equals to plus minus 1.
Yeah. So basically, the determinant will turn out to be K into A square minus 1. You can compute it, equal to 0. So K is 0 plus or minus 1. Out of these, the only option that we have is 0. Right, so I've skipped the computation of determinant. I hope that is okay. Is this okay? Any doubts? And I'm not sure about this. Maybe it will work, but I see that this is a easier. See, all this need not be done. You could have directly put the vectors and set the determinant to 0 and got a quadratic and found the value of k. So this whole thing was done just to show you why that actually works. So I'm guessing this is a simpler method. So If you have any comments or suggestions, questions. No questions. Okay, let's go ahead. So let V be R3 and F is R. So V is a vector space over the field F. Under the operations, so this is the same as what we were doing. You take a vector, component wise addition. And the scalar multiplication is the scalar gets multiplied with each component. Which of the following is a subspace of V? So let's just quickly recall what is subspace and how do you check if something is a subspace. So if you want to algebraically look at it, you have some subset W of V and we're saying that this itself is a vector space. So there is just a condition which you have to check if it is a subspace. I think it must have been, it is done in the class. So is a subspace. So first of all, you will say W is non-empty. I mean, we don't want to look at empty subsets. Or easier way of equivalency or easier way of checking this is the vector 0 should belong to W. So let's say equivalently 0 belongs to W. Whatever is the 0 in the vector space that we are talking about. And second thing is you take any two vectors in W and any two scalars in the field, then the linear combination should belong to W. So if these two conditions are satisfied, then we say that W is a subspace. So this is the algebraic definition. You can go by this and check.
Ma'am, AW1, no? Not alpha W1.
Sorry, thank you so much. AW1 plus BW2 belongs to W. So you can go by this and check it. But what does it pictorially mean? Like, you know, these equations that is given here, if you are used to looking at some graphs and how these look like surfaces, in fact, nowadays we have these plotting software. So you can just plot it and see what the graph is. Let's see if using that, can we see if something is a subspace. So what does it mean? We have, let's say, R3 and we have W and we have two vectors. So you have W1 and W2. When we say A times W1, what does it mean? It is some rescaling of A. So it could be, it means the direction is remaining the same, but it is getting rescaled by some factor. It could be in the same direction longer, or it could be shorter, or it could be in the opposite direction. Any of these is some for all the possible rescalings. And when we say B times W2, it is again the same thing. So it could be any of these depending on what is your value of B. Now we are saying that A times W1 plus B times W2 should belong to W. So you take any of these vectors which come on this red line. So you just extend this line. And any of the vectors which come on the pink line. And their sum should be also contained in W. So let's fix this as A times W. And let's say this vector of B times W2. So what will be the sum? If you remember how to take the sum of vector, the parallelogram law. So it will be something like this. Okay, so why I'm saying this is, if you understand pictorially, you can in some way guess which of these are possibly subspaces, right? See, you can definitely check these conditions and see if it works out, or if it doesn't seem like it's working out, try to get a counter example and so on. But I mean, in my personal opinion, I feel that this understanding will give a better edge. So let's do an example. Let's do example B. X square plus y square is z square. So the surface looks something like this. Okay. So this is the surface of, or this is the set of x comma y comma z such that x square plus y square equal to z square. This is how it looks like. So looking at this, can you tell if it's a subspace? Forget the definition and everything. If you've understood what we've done, can somebody say, is this a subspace? So you just check. Yeah, somebody says no. Can you, would you want to explain why you're saying no?
Sum of two vectors may not belongs to the surface.
Yeah. So what he's saying is, you take, see, you look at the surface. This is like two cones, okay, infinite cones. So you take some vector here. This lies on the surface. You take some other vector here. This also is lying on the surface. But when you take the sum, the parallelogram law, it is going outside the surface, right? So the condition of the vector space is not being satisfied. So sum of the vectors is not belonging to the subspace, subset that we are looking at. So it is not a subspace. So this is not a subspace. Similarly, we can try for the other two. So x plus, okay, the other two are easier to plot, so I haven't got a picture. X plus y plus z equal to 1. So what will that look like? So x plus y plus z, it will be some plane, but okay, I will not be able to draw anyway. Yeah, the point is it won't pass through 0, 0. It is some plane through the origin, but a translate of it. So x plus y plus z equal to 0, you take that plane and some translate of it will be x plus y plus z equal to 1. So if you look at this condition, if the C, option C, it is set of all x, y, z such that x plus y plus z equal to 1. So just the 0 vector does not belong to this. That itself tells that it's not a subspace. And you can also check that it won't be closed under taking sum. But yeah, this is an easier way. So even this is not a subspace. Now the last one, x, y, z such that x is greater than or equal to 0. So option D is x, y, z such that x is greater than 0 is like this half. If this is the x-axis, y-axis, z-axis, one half of it. So if you imagine in three-dimensional space, you're just dividing it into two parts and you're taking the positive x-axis. So is this a subspace?
No, madam.
Why is it not a subspace?
They may not be used for some inverse elements.
Yeah, not inverse. When you take a negative scalar, right? So you take some vector. Okay, let's say this is w. The w belongs to D. But what happens to minus w? Minus w is somewhere here, right? So this doesn't belong to D. So this is not a subspace. So by eliminating all the other options, we get that A is right. But let's actually check that it is right. Let us verify properly using the definition. So what is A? A is set of all x, y, z such that x is equal to 0, right? So what are the two conditions that we have to verify? First, we have to verify that 0 belongs to W. So this equivalent condition is most often easier to verify. We have to show that 0 belongs to W. And you take any two vectors in W and any two scalars, we want to show that the linear combination, corresponding linear combination is also in the set. So A. So 0, 0, 0 satisfies this condition, right? See, what is the condition? The condition is that you take a vector, this coordinate has to be 0. That's what it means by x is 0. So definitely this belongs to A. Now let us take W1 and W2 in A. So how will W1 look like? You know that the first coordinate is 0 and then you'll have something and something. So let's call it Y1, Z1. And how will W2 look like? First coordinate is 0 and then you have,
Y to Z.
so where all of these Y1, Z1, Y,
आत बसतो का मी तर जास्ती नाही थोडंच राहिलंय
and let's take two scalars. So we want to check what happens to AW1 plus BW2. What is this? A times 0 Y1 Z1 plus B times 0 Y2 Z2. So this is 0 plus BZ2. But yeah, the point is that the first coordinate still remains 0. So this belongs to A. So in fact, A is a subspace. Any questions?
नो मॅम
Okay. Yes, please.
Madam, I have a question,
No
but not
problem.
related to this. As suppose we are taking a set of 2 by 2
Okay.
matrices over the field R,
Mm-hmm.
so it is a vector space. Can we take a subspace as a set of all asymmetric matrices?
That's a good question. Wait, you said symmetric or asymmetric? And
It is
asymmetric
asymmetric.
asymmetric
what do you mean by asymmetric? Not symmetric.
The question has given in the assignment. So the word mentioned is asymmetric.
Okay. We are not allowed to solve questions from the assignment, so I'm sorry for that.
I'm checking what is asymmetric. It is not a symmetric matrix. Is called asymmetric.
Yeah. So if it's an assignment question, since it is going for the course evaluation, I think we're not allowed to solve it. So
Okay, but what is asymmetric matrix? I think asymmetric matrix is by the condition of a subspace. It is not a subspace, which means the zero element is not asymmetric. So that's why this is not a subspace. But they asked what is the dimension of the subspace which the matrices are asymmetric.
maybe they mean skew symmetric kind of matrix.
It may
Actually,
be asymmetric, or the space is not given. Maybe.
oh, okay. Then maybe you can put it up in the discussion forum because even I asked you what do you mean because it was a new word for me. So I don't know. What
Okay,
is
okay, ma'am. Thank you.
yeah.
The question itself is not, it is confusing question.
Okay.
Asymmetric means is it skew matrix, or it's not symmetric matrix?
Okay. Maybe then you can put it up in the discussion forum. The instructor or the course TA will attend to it. I don't know what they meant. Yeah. Is there any other question?
No,
Basis
madam, you
of
can proceed.
n cross n matrix is
Mm-hmm.
n square, no?
Dimension is n square. Basis has
Dimension
n
is n
square
square.
elements. Yeah. So what would be the basis? You just put one in each entry and the other 0. So this will be a basis, which will be n square. Any more questions? Okay, we have some more time. So, and one last question. Yeah. So we are looking at vector space V is the set of all functions from real numbers to real numbers, and we are defining addition. So you take two functions. What do you mean by sum? So the sum of the functions, see when we say it should be a function again, right? So we have to specify what is its value at some real number x. So we define it to be f of x. So this plus just means addition in the real numbers. And we define scalar multiplication. So you take a function, you take a scalar, you want to make sense of what is this c dot f. So c dot f evaluated at a real number x is nothing but c times f of x. F of x is a real number, you have multiplication in real numbers, so it is c times f of x. Now we have given two subsets, in fact there will be, okay, yeah, two subsets. So VE is all even functions as they say. It is set of all f such that f of minus x is equal to f of x. So it means if you draw the graph of it, it is symmetric about the y-axis. So something like this, right? And we are looking at the next one is VO, which is all functions such that f of minus x is minus f of x. So if you look at it graphically, so positive side if it's something like this, negative will be opposite like this. I mean, I'm supposed to be drawing similar. Yeah. So it is symmetric about the origin. Okay, so trick about y-axis and symmetric about origin. So we are given few options. Are they subspaces of V? Is there sum the whole of V? What is their union and what is the intersection? So subspaces we'll do one, the other will be a similar argument. So what is we'll do it for maybe even functions. F of minus x equal to f of x. So it's the same thing. Does 0 belong to this space? When we say 0 here, whatever is the meaning of 0 in this vector space. So here we mean the 0 function, right? Here by 0 we mean 0 function, which is basically f of x equal to 0 for every x. So definitely this satisfies that f of minus x is equal to f of x, right? So this belongs to V. Now, if you take two F1 and F2 in VE, so what does it mean? Both of these satisfy the condition. So that is F1 of minus x equal to F1 of x, and F2 of minus x equal to F2 of x, and we'll take two scalars. So let A, B belong to real number. We want to check what happens to A F1 plus B F2. So let us evaluate it at minus x. So by definition, what is this? So you treat this as one function plus some other function evaluated at minus x. So we know that that is nothing but A dot F1 evaluated at minus x plus whatever this function B dot F2 means evaluated at minus x. Again, now we'll use how we have defined scalar multiplication. So A dot F1 evaluated at minus x is nothing but the real number A into F1 evaluated at minus x plus B into F2 evaluated at minus x. So now you use the condition that we know. F1 of minus x is equal to F1 of x, and F2 of minus x is equal to F2 of x. Now you go back and see that this is nothing but A dot F plus B dot F2 evaluated at x. So what have we got? This large function, if we call it f. So we have got this capital F at minus x is equal to capital F at x. So this large function which we call as capital F belongs to V. So A dot F1 plus B dot 2 belongs to VE, which gives that V is a subspace. And similarly, you can check for the odd functions. So these are subspaces. Since this asks which of them is false, so this is not false. Okay. The next option is VE direct sum or sum VO, is it V? It's a linear sum of V and VO. So we'll just come back to this option. Let's just go to C and D. Is the union whole of V? That is, when we say union, is every function from R to R either an odd function or an even function? That is not true, right? Not every graph looks like this. You know, not every graph is symmetric about y-axis and about the origin. You just take some random function like.
You have written f of minus x equal to fx. It is f of minus x is equal to minus fx, not fx.
Uh,
F of minus x is equal to minus fx.
No, ma'am. Even function.
Am I wrong? Even function is my f of minus x equal to f of x, right?
F of minus, it is given f of minus x is equal to minus fx.
No,
Not
this
fx.
one, VE.
In the first case.
It's okay, right? What I've done? We just
You
checked
wrote,
that. Oh, okay, somewhere else I wrote something wrong.
you wrote here f of minus x is equal to fx, no?
This one?
Yeah, but it is f of minus x is equal to minus fx, no? It is.
That is for V naught, sir.
That, see, we are given two sets, VE and V's not. So we did it for only one of them.
Okay, okay.
The other one you can just do similarly. It's very similar.
Okay. Okay.
Yeah. So is it clear that the third option is, see, this is not true. The statement is not true. Since they've asked which one is false, it is correct. Is that okay? The union is not the whole of V.
Yes, it is okay.
It's okay. Okay. Now the intersection is 0. That also you can see it is not a very difficult thing, because if a function is odd and even, what does it mean? So suppose f belongs to VE intersection VO. So what does that mean? Since it belongs to VE, f of minus x equal to f of x. Since it belongs to VO, f of minus x equal to minus f of x. So LHS, both sides we have f of minus x. So combining these two, we get f of x equal to minus f of x. This is for every x. And the only possibility is f of x equal to 0, which means it is a 0 function. So the intersection is 0. I'm way beyond time. So just this one thing. So it says VE sum V naught is V. So just a subtle difference between option B and option C. In option C, we are saying that every function is not, you can't say that it is either an even function or an odd function. But option B is saying, can every function be written as a sum of even function and odd function? That is the subtle difference. Okay. So option B is just to say what it is saying. Can every function be written as a sum of, let me not use this word, of an element in VE and an element in VO. And in fact, you can check that that is true. So I'll just give you what it is. You take any arbitrary function. So you can write it as f of x plus f of minus x by 2 plus f of x minus f of minus x by 2. So you can check that one of this will belong to VE and the other will belong to VO. So this will give you that V is VE sum VO. I'm sorry for overshooting time. Yeah, so we'll end the session here. If you have any more doubts, you can ask. So